Hello. By the kind courtesy of Center for National Distance Learning and Open Schooling, CENDLOS, we bring you Core Mathematics for SHS2. My name is Betty Osei. Today we are solving equations involving indices, a continuation of our last lesson. I hope you remember what we learnt about the laws and the properties of indices. I hope you remember that we also learned how to simplify expressions using these laws and properties. By the end of this lesson, you should be able to use the laws of indices and the properties of indices to solve a given variable in an equation involving indices. In solving an equation involving indices, we will use the laws and properties of indices to either first make the bases on both sides of the equation equal and then equate the exponents, or we make the exponents on both sides of the equation equal and equate the bases. There are only two approaches we are going to use, and both of them are very easy. So let's go. For instance, if you have 3 to the power x is equal to 3 to the power y, then we say that since the bases are the same and these expressions are equal, the exponents x and y must also be equal. Now, this is one principle we are going to be using throughout our solutions. So let's look at a few examples. The first one says, solve the exponential equation 2 raised to the power x is equal to 32. Now you see, the exponent is the variable in this question. So we will try and change the bases so that both of them are equal. Then we can equate the exponents. So we have 2 raised to the power x is equal to 32. Now, since the variable is to base 2, ask yourself if you can write the other side as well to base 2. Now, using repeated factors, we are going to write 2 raised to the power x to be equal to 2 times 2 times 2 times 2 times 2, which is 2 raised to the power 5. I'm sure you know that 2 raised to the power 5 is 32. So then we have 2 raised to the power x is equal to 2 raised to the power 5. Now you see the two sides are equal. The bases are the same. So we can say the exponents are also equal. So we conclude that x is equal to 5. That was very easy, wasn't it? Let's look at another example. We have to solve for x, and we have 5 raised to the power x is equal to 125. Again, you will find that the exponent is the variable. So we will try and change the bases so that they are equal. Then we can equate the exponents to find what x is. Now, so what do we do here? You can find from the question 5 raised to the power x equals 125, that we can change the right hand side to repeated multiples of 5. So we are going to write 125 as 5 times 5 times 5. And that will be equal to 5 raised to the power x on the left hand side. Now again, these two sides are equal. So if the bases are equal, we can very easily compare the exponents. So we find x is equal to 3. Now the next example. We have 7 raised to the power x is equal to 49. Once again, our exponent is the variable. So let's try and write both bases to be equal. And I'm sure you know that 49 is 7 times 7. So we are going to replace the 49 by 7 squared. So we have 7 raised to the power x to be equal to 7 raised to the power 2. These two sides are equal. The bases are the same. So we can very easily conclude that x is equal to 2. The next example says 3 raised to the power x is equal to 81. So x, which is what we want, is an exponent. So let's try and write the bases to be equal. So write 81 as a number to base 3. We know that 81 is 3 times 3 times 3 times 3. So that is 3 raised to the power 4. So we are going to change our question to become 3 raised to the power x is equal to 3 raised to the power 4. Again, these two sides are equal. The bases are the same, so the powers must also be equal. So we say x is equal to 4. I'm sure you'll be able to do the next question all by yourself. Once again, as you can see, the exponent is the variable. So try and write both of these sides, the bases on both sides, to the same base, a smaller base. Now, can you think of any number that will multiply by itself to give us 8 and 128? Well, I can. We're going to write our 8 as 2 times 2 times 2. So we have 2 times 2 times 2 raised to the power x on one side, and 2 multiplied by itself 7 times on the other side. Now writing that again, we have 2 raised to the power 3 in brackets or raised to the power x on your left hand side. On the right hand side, we'll have 2 raised to the power 7. Now when we remove the brackets from the left hand side, we're going to multiply the exponents. I'm sure you remember that. That will give us 2 raised to the power 3x to be equal to 2 raised to the power 7. Now we have one side equals to the other side, and we have the bases to be the same. So it means that the powers should also be equal. So we are going to say 3x is equal to 7. Now we have to find x. We solve that little equation, and it gives us x equals 7 divided by 3, which is the same as 2 whole number 1 over 3. So as we go along, I want you to be trying the questions, and then you see whether you're getting the same answers with me. The next question says 81 raised to the power 2x is equal to 27. Again, our exponent is the variable. So can we write 81 and 27 as a number with a smaller base? Yes. So that is what we are going to do. We will write 81 as 3 times 3 times 3 times 3 raised to the power 2x. And then on the other side, we'll have 3 times 3 times 3. Then we will remove the brackets from the left-hand side and multiply our exponents. So that will give us 3 raised to the power 4 times 2x. And that will be equal to 3 raised to the power 3. That gives us 3 raised to the power 8x on the left-hand side and 3 raised to the power 3 on the right-hand side. Again, as you can see, both sides are equal. The bases are the same. So our exponents can also be equated to each other. So we'll say 8x is equal to 3. And then x would be 3 over 8. Now, if you are getting these questions, it means you are maturing and now you have grown from drinking milk to eating meat. That is very good. Let's look at the next question. We have 25 raised to the power 5 minus x to be equal to 1. Now, what do you think we should do here? Again, we have to write both bases to be the same. Remember, we learned something in our last lesson. We said that 1 can be written as any number raised to the power 0. So what we are going to do here is to replace our 1 with 25 raised to the power 0. So we'll have 25 raised to the power 5 minus x is equal to 25 raised to the power 0. Now, since both sides are equal and the bases are now the same, we can equate our powers. So we have 5 minus x to be equal to 0. So we can easily find x. That gives us x to be equal to 5. Good. We're going to move to the next level. Now this time our question is x raised to the power 3 is equal to 64. I'm sure you can see that this one is slightly different. This time our variable is in the base. So we try as much as possible to make our exponents the same. This is not difficult at all. We have x raised to the power 3 is equal to 64. Now ask yourself, which number multiplied by itself 3 times will give me 64? That number is 4. So 4 times 4 times 4 is 64. And when you replace that, your question becomes x raised to the power 3 is equal to 4 raised to the power 3. Again, both sides are equal. This time our powers are the same, so the bases must also be equal. And therefore we say x is equal to 4. I hope you are getting it. In the next question, we have 8 minus 5x into brackets raised to the power 6 to be equal to 9 raised to the power 3. I'm sure you can see that the variable is in the base. So we have to try to make our powers equal. So we are going to go to the right-hand side and rewrite that expression. We know that 9 is the same as 3 times 3. So we'll write our 9 as 3 squared, all raised to the power 3. But we'll leave our left-hand side alone. Now then, the question becomes 8 minus 5x raised to the power 6 is equal to 3 raised to the power 6. I'm sure you can see why we are getting 6. We are using the law of power of powers. We have to multiply our powers. Now that we have both sides to be equal and our powers are the same, we can very safely compare the bases. So we say 8 minus 5x is equal to 3. Then we solve that little equation and we get the value for x. So 5x is equal to 5 and x is equal to 1. Now, in the next example, we have the variable in the exponent but on both sides. But it doesn't change anything. The same process. So let's look at the solution. Because the variable is in the exponent, we have to make sure that our bases are equal. So we are going to go to the right-hand side and write the 25 as a power of 5. That gives us 5 raised to the power x squared minus 1 to be equal to 5 squared raised to the power 1 minus x. We are going to use the power of powers here to simplify the powers on the right-hand side. So we have 5 raised to the power x squared minus 1 to be equal to 5 raised to the power 2 minus 2x. Both sides are the same. The bases are equal. So it means the powers or the exponents must also be equal. So that gives us x squared minus 1 to be equal to 2 minus 2x. We bring all these terms to one side and we get a quadratic expression that says x squared plus 2x minus 3 is equal to 0. We need to find x. It means we haven't finished our work. To solve a quadratic equation, we can factorize. So we are going to factorize this expression. That will give us x minus 1 times x plus 3 is equal to 0. And that gives us x to be equal to 1 or negative 3. Now, if you can work questions like this, it means you have started breaking bones. That is very good. And I hope you are enjoying this part of indices. We are going to go a step further again. This time, we shall have radical operations. Now, the next question says 1331 to the exponent x minus 2 is equal to the cube root of 11 raised to the power x squared. Now, the question may not be friendly, but the same things we've been doing is what we are going to do, and you will get your answer. So the first thing we are going to do is to change the bases to be the same. The number 1331 can be written as a multiple of 11. So we are going to change it to become a multiple of 11. And then we can write the other side as well as a number with a fractional index. That will make our question look a bit more friendly. So then we are going to have 11 raised to the power 3 or raised to the power x minus 2 to be equal to 11 raised to the power x squared over 3. I am sure you know where we are coming from. Now, once we can write both sides of this question with the same base, then we can equate our exponents and go on to find x. So now we have 3 into brackets x minus 2 to be equal to x squared divided by 3. This is an equation with a fraction. So the first thing we do is to multiply through by 3, which is the denominator of our fraction. So we get 9 into brackets x minus 2 is equal to x squared. Remove the brackets. You get 9x minus 18 is equal to x squared. Bring all the terms to one side, and you are getting x squared minus 9x plus 18 is equal to 0. Again, we have a quadratic equation. we need to factorize. Then we can find x. So factorizing, we get x minus 3 times x minus 6 to be equal to 0. That gives us x is equal to 3 or x is equal to 6. So you see, that question that didn't look friendly can be easily solved. Now, exponential equations can also involve two variables. It means we are going to be cracking harder bones, but I'm sure you're up to it. This means we must have two equations. And this means we must solve them simultaneously. Remember, we learned how to solve simultaneous equations. So let's look at this example. This time we have two equations. The first equation is 2 raised to the power x minus 2 is equal to 8 raised to the power y minus 2. And the second equation is 9 raised to the power x minus 4 is equal to 3 raised to the power y. We are going to consider the first equation. Try to make the bases the same and equate the exponents. So we have 2 raised to the power x minus 2 is equal to 2 raised to the power 3 all to the power y minus 2. Now, once the two sides are equal, we can equate the exponents. That will give us x minus 2 to be equal to 3 into brackets y minus 2. We can expand this group-like terms and simplify. So then we get x minus 2 to be equal to 3y minus 6. And finally, we get x minus 3y is equal to negative 4. We are going to label this as equation 1. Then we go and pick our second equation and do the same thing. So this time we are taking 9 to the power x minus 4 is equal to 3 to the power y. We have to make the bases the same. So that will give us 3 raised to the power 2 for 9 raised to the power x minus 4 on our left-hand side. On the right-hand side, we have 3 raised to the power y. We are going to equate the exponents. So we have 2 into brackets x minus 4 is equal to y. Remove the brackets and we get 2x minus 8 is equal to y. Rearrange this and we get 2x minus y is equal to 8. Then we'll label this equation 2. Now this is only half of our work. We now have to take these two equations, solve them simultaneously, because we have to find x and find y. Now, which method do we use? You can use any of the methods we learned for solving simultaneous equations. Take your time and solve the two equations. And when you do that, you get x is equal to 5 whole number 3 over 5 and y is equal to 3 whole number 1 over 5. Good. Can we take another example? So this one is very similar to the previous one. Again, we have two equations and you have two variables. And the variables are in the exponents. So what do? We take one equation first, work on it. Then we take the second equation, work on it. Until finally we take the two resulting equations and solve them simultaneously. So let's start. We have 5 raised to the power x minus 2 times 5 raised to the power 2 minus y is equal to 25. Then the second equation says 9 raised to the power x minus 4 times 3 raised to the power 2y is equal to 1. Let's take the first equation. And in the first equation, we're going to change the 25 on the right-hand side with a base of 5. Then we'll use the multiplication law to simplify the left-hand side. Now that gives us 5 raised to the power x minus 2 times 5 raised to the power 2 minus y is equal to 5 raised to the power 2. Now on the left-hand side, we can use our multiplication law, and that means we will take the common base, which is 5, write it down, and add the powers. It doesn't matter that your powers are expressions in terms of x and y. Just add them. So that gives us 5 raised to the power x minus 2 plus 2 minus y is equal to 5 raised to the power 2. Now we leave our bases, take our powers and equate them. We get x minus 2 plus 2 minus y on the left-hand side is equal to 2 on the right-hand side. Remove the brackets on the left-hand side and simplify. And you get x minus y is equal to 2. We will now call that equation 1 and put it aside. Then we go back and take the second equation. That equation says 9 raised to the power x minus 4 times 3 raised to the power 2y is equal to 1. The exponent has the variable. That means our bases must be equal. So let's see whether we can write this expression with the same base throughout. So that gives us 3 to the power 2 all to the power x minus 4 times 3 to the power 2y is equal to 3 to the power 0. I hope you haven't forgotten the 0 index rule that we looked at. That helps us very much here. Now we have both sides as numbers or expressions to base 3. So we can compare the powers. So now we have 2 into brackets x minus 4 plus 2y is equal to 0. Remove the brackets, group like terms, simplify. And we get 2x minus 8 plus 2y is equal to 0. Now that expression can be divided through by 2. And when we do that, we get x plus y is equal to 4. Now that is going to be our second equation. Now these two equations both have x and y. The only way you can find x and y with two equations is by using simultaneous equation. Now there are two methods. You can either use substitution or you use elimination. Now whichever method you want to use, you are free to use. But when you do that, you get x is equal to 3 and y is equal to 1. Good. If you are comfortable with this work, you have gone very far in maths and you need to congratulate yourself. Well. We have looked at how to solve equations involving indices. We have learned that to solve an equation involving indices, we should first make the bases on both sides of the equation equal and then equate the exponents, or we make the exponents on both sides of the equation equal and then we equate the bases. We also noted that the resulting equation can either be linear or quadratic or even simultaneous equations. Now, in each case, we must apply the appropriate technique to solve the equations to find the value of our variable. This brings us to the end of our second lesson on indices. And I hope you are going to practice, because if you don't practice, you will forget some of the things we learned. Now, next time, we are going to continue, and then we will look at the relationship between indices and logarithms. Remember, keep solving equations. Try some of the questions in our notes and make a date with me for another interesting lesson. Bye-bye.